This conference will now be recorded.
Good morning, guys, and welcome to a fresh new session on credit risk modeling using SAS. And this is Tanmay Ganguly welcoming you for the sessions. And we have a new participant today, Umang Shah, joining the discussions from here, right? So, just for the convenience of everyone and to put everyone on the same page, what I'll do is I'll just do a very quick recap of the discussion and we'll take it up from there. So, we were trying to understand a few important questions as far as risk management is done, right? So the most basic part we had started a discussion with is the customer's credit life cycle. So we start wanted to understand that what is it all about, right? And how is it that at each stage the customer's credit life cycle is the risk managed, right? So what are the techniques of managing the risk? So over here, some of the important questions that we have over here was that what are the different ways? So one important way was the scorecard, right? So a customer's credit life cycle generally begins with the onboarding of a customer on the books of the bank, and from there, uh, it goes passes through the behavior stage where the borrower is repaying the loan, and finally the outcome stage where the borrower is ending up as a defaulter or as a borrower who is, you know, is ending up as a defaulter or as a borrower who is kind of closing the account by paying off the full dues of the bank. Now, at each stage of these cycles, the banks implement their respective scorecards. So while originating a customer on the books of the bank develops or looks into an acquisition scorecard. Right? So it looks into how an acquisition scorecard is. So how is it that you can distinguish between the origination risk of the good and the bad borrowers, right? So from that perspective, the next thing that we need to understand is the following: that once the borrower is onboarded, right? So then what happens? So at that stage, the account management activities initiate, where the bank monitors the payment patterns and the payment habit of the bank. And once that is done, right? Once that is sorted, so that is sorted using a behavior scorecard. So a behavior scorecard enables a bank to look into or to help them distinguish between the good borrowers, the potential good and the bad borrowers, basis their payment patterns, right? And finally, after assuming whether if a borrower is defaulted, the next thing is to understand is to develop a collections scorecard to assess what is the borrower, who is the borrower, from where the money can be collected back. So these are the three broad kind of scorecards which are implemented, right, by a bank. Now there can be excuse me. So there can be other kind of scorecards which are implemented, but these are the three broad kind of scorecards which are implemented, right? Now, what we want to do over here is we want to understand the different stages through which a borrower or a bank should pass, through which the development exercise of a scorecard should pass. How should a scorecard get developed? So that is what is being discussed in these present discussions, right? So for building up any scorecard, the first thing is to perform a gap analysis, right? So while performing a gap analysis, typically there can be two scenarios. One scenario is where the borrower has a scorecard, right? Or where the bank already has a scorecard which is deteriorated in performance, and what they are doing is they are upgrading that. So you are redeveloping the scorecard to solve that problem. So that's one. The second is where the bank does not have a scorecard and you're suggesting to develop a new scorecard. So there are multiple requests. So there are multiple possibilities. However, the basic idea is to identify the gap that exists in the present scorecard, the adverse impact that it can have on the portfolio. And from there, what you do is you start develop, you move into understand, you move to understand the next stages. Now, so the basic stage for developing any scorecard is to, to extract the data, right? and to identify what is the key dependent variable and what are the key independent variables. Once you have understood that, the next thing to come out is the next thing to that we should that we need to look into over here is that what exactly is or why is it that we would need a scorecard for so how is it that we would assess the quality of the data of the independent and the dependent variables, right? So after we have done a data quality check exercise where we have looked in for the missing observations, so basically the idea of performing a data quality check for a scorecard is to assess the missing observations in it, to assess whether any of the continuous variables have any abnormal trend, or whether any of the variables would have, whether any of the categorical variables would have a categorical, would have an abnormal concentration. So once you have tested your variables for these abnormalities or their unusual trend in the behavior of the variables, the next thing that we will be doing over here is we would start or we would kind of try to capture the overall behavior of the data. So we would kind of try to capture that how is it, we would try to capture how is it that we can identify the key variables in the data. So up to the data quality check, up to the point where you are assessing the quality of the data, you are trying to assess that data from its structural or from its what should I say, from its field perspective, from the nature, from the way the variable has been populated, the way the variable has behaved. Right now, once you have identified that, once you have done your data quality check, now you stand at a position where you know that so you stand at a place where you know that your data is structurally it's fine. So there are no structural issues with the behavioral issues with the data, right? Now the next part is to identify whether the next part is to identify whether the variable can discriminate between the good and the bad. And it is this discriminatory capacity of the variable that we want to study. Right. So in the last class's discussion, we started off by talking about assessing this discriminatory capacity of a variable and so on. Right. Now, in today's discussion, we will talk about the more industry relevant approaches that we generally use. So, what we generally do over here is we assess the discriminatory capacity of a variable. We talked about the mean difference tests. We talked about the parametric and the non-parametric tests for assessing the difference in the explanatory capacity of categorical variables. We talked about the Kolmogorov-Smirnov test as well. Now, we also identified a limitation of these tests, that these do not help us transform the variables, right? Because whenever we are doing any kind of regression analysis or modeling exercises, the continuous and the dependent variable has to be continuous in some way or the other. So therefore, what we need to do is we need to make a transformation of the independent variables which will be used for model development. And hence, we need to undertake a common transformation. And that is where we said that this approach that we had initially suggested lacks. Hence, the weight of evidence approach, the weight of evidence and information value approach is most widely used in the industry. So I do not say that this is the only approach which is used, but most it is the most important, or it is the most widely used practice. So over here, so we will start understanding afresh, right, the weight of evidence and the information value approach for, say, for variable selection. We'll try understanding number one, we'll try and understanding the WoE approach, WoE IV approach for variable selection. So that's one. weight of evidence, IV approach, right? So this is precisely one part. Now the next thing that comes in over here is to understand. Uh, so before we go into this, right? So we need to understand why weight of evidence approach. What is weight of evidence all about? Okay. Okay, so before we start, okay, Piyush has a question over here. Then why can't we use dummy variables instead of weight of evidence approach? Now, dummy variables are mostly used or would be used if you have a continuous variable, right? Because you find out the expected value of y given a particular category of the dummy variable. Now, dummy variable itself is a categorical variable, right? And you compute the mean and the average behavior, right? But that is specific to a linear regression model. Over here, we are trying to understand the discriminatory capacity of a variable for a categorical, where the dependent variable is categorical in nature, right? So dummy variables are not generally used to, you know, they are not generally used to assess the discriminatory capacity of a variable. What they are generally used is to categorize or identify the behavior, for a categorical variable in a linear regression framework. We try to understand the different impacts of the dummy. So, so over here, because we have a categorical variable, right, dummies may not be that useful for us to understand. Now, broadly, we use the weight of evidence approach because we would want to assess not only perform a common transformation, but also we would try to understand the discriminatory capacity. Now now what you say, I do understand, right? So by incorporating a dummy, I can check the impact effect, right? The intercept effect, and that difference will tell me the discriminatory capacity. Now, the question that comes out over here is that it is possible because you have an intercept in a continuous model, right? Where your dependent variable is continuous, where y is continuous. But over here, y is not continuous at all. So therefore, dummy approach would not be a feasible one.
So Tanmay, I have a question here. So when we
Uh-huh.
take this information value and weight of evidence approach, here also the
Mhm.
variable after like the information value, it takes a different shape, and then again it is difficult to track it back to its original
No, 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 no,
form
no,
and
no,
original.
no, no. It's not like that. It's not like that. I'll come to that. I'll come to that. Now, why weight of evidence and information value approach? I'll be coming to that, right? So it has something to do with the way the models are developed, and the way the models are developed. Weight of evidence approach is absolutely synced to the approach of the model development. So I'll just come to that. Okay. Now, so yeah, so that is the most important question that we'll try to address today. That why is this approach? Why this approach? Okay. Now, before I go to this, I'll take a question that Harish has. Uh, Harish asks, can you use an interactive variable in a scorecard? So, what do you exactly mean by interactive variable, Harish? I am not getting the jargon. Might be it's something that I use with a different terminology. Can you just explain this concept of interactive variable for my understanding? Okay. Okay. Yeah. So we call it the covariates. Yes, obviously you can create two variable. You can use two variables, and you can create a new variable, which you call the covariates. And ultimately, yes, we see that these derived variables are the ones which finally go into the model, right? But when we are checking for the the weight of evidence and the information value for the variables, we do it on the primary variables, because if the primary variables are highly informative, any covariate created out of it will also be uh, any covariate created out of it would also be a highly informative covariate, right? So once the covariates are created, we do a information value check on that as well, and from there you can see that okay, yes, these variables are highly uh, yeah, useful. Now, talking about interactive variables, yes, they can arise as an exercise, right? So as a specific covariate. Let's say uh, for credit cards, right? So one very important variable which is used is your utilization variable. Right. So your utilization variable is your limit by balance, right? So what you do is you can think about it as limit into 1 by the balance. So that's a kind of an interactive variable. So where you are looking into the impact of, or you're creating a new variable as an impact of two particular variables. Or there can be two variables that you, new covariate which you create by putting in two variables in a multiplicative fashion. So yes, there are these variables, and mostly the final set of variables when we reach to, it's mostly the covariates or the derived variables which find a way into the final model, right? So the primary variables are composed, they're pulled together into one single variable, right? So does that answer your question, Harish? Great. Okay, fine. So let's start with this answer. Let's start addressing this question. Why it is weight of evidence and information value? What is WoE IV approach? So let's move on to the next page. Now, before we start on with this, let's try to assess one particular thing. Then what is the dependent variable for a scorecard? So y equals to 1 if the borrower is a defaulter is a defaulter equals to 0 otherwise. So this is say in a given scorecard, right? Say in a behavior scorecard. And what I have is the following. So I'm trying to develop a behavior scorecard for, let's say, a credit card product. So this is the bad definition for a credit card, right? So over here, so So over here, what we have is, so y equals to 1 if the borrower is a defaulter and the product is a credit card. Now I have multiple variables. Like, let's say I have one of the important variable is the balance variable. The next variable that I have over here is a limit variable the next that we have over here is the delinquency variable in days. In, in days past due. Now the next thing that we have over here is, so over here what we have is credit card, right? So we have balance, we have limit, we have delinquency. The next part that we have over here is, so after credit cards, the next thing that comes up to us over here is the following. So I have balance, I have limit, I have delinquency. Say I have purchases, right? I have payments. Now, if you see all these variables, right? So they are all continuous variables, right? And the dependent variable that I have is a continuous variable. However, when I'm trying to create a scorecard, right? So if I try to create a scorecard, how should I go about it? I should have the score categories, right? I should have the score categories, and to each category I must have the different names and all. Right? So basically for each category I must have associated score. So this is what this is what the idea of scorecard is. Ki, for a given variable x1, category 0, so category 1, the score is 0. Category 2, the score is 10. Category 3, the score is 14. So it must increase or decrease as I move across the categories. So one very important role over here is to convert these continuous variables into a categorical approach, right? Just in case you would want to see how a typical scorecard would look like, I'll just refresh that part because understanding that portion is very important. Yeah. So, for example, if you have a look into this acquisition scorecard, which I had created, this is a sample scorecard which I had done for representation purposes. So, what we have is overdraft account status, we have savings account status, we have fixed obligation to income ratio, we have number of inquiries made, right? And each of these variables, they are converted into multiple categories. Now, how these categories are created, I'll be coming to that. I'll get that to you as well. Right. So you have savings account status, you have fixed obligation to income ratio, you have number of inquiries made by the customers, and so on. And to each category, a score has been assigned, right? So the question that comes out is how do we reach to these variables? How do we create the categories, and how do we create the score corresponding to each categories, right? So similarly, and one very important characteristic is that each of these categories must rank order in terms of their riskiness. Right. So this is what we have. So this is how a typical scorecard would kind of look like, and what we need to do is we need to understand how each of these categories are created, how the scoring is done, and so on. So the next part that we have over here is, fine. So now over here, now let's think that I want to understand whether the balance limit or the balance variable will be an important variable or not. Now the question that comes out is that, Tanmay, why do you say that you have to convert it into categorical variables? These are all continuous variables and you can do it that way. But the fact that they need to be converted into a categorical variables, and for each of them weight of evidence need to be computed, and hence the information value comes out. So this entire channel should work out in a very specific manner. So how do we go about doing it? Let's say I have this way. Now, so how does the model work? So to understand why this transformation is being done, we need to understand how would the scorecard or the model would work, or how, or we need to understand that how do we need reach to these specific variables. Now you know that in any predictive model there are two parts. One is a dependent variable, the other is an independent variable, right? So generally, the regression or any kind of predictive modeling framework looks something like this. You have the y variable, right? Then you have the beta. Then you have the independent variables. You have beta 1 x1 plus beta 2 x2 plus beta k xk. Beta k xk. So what we have is beta 0, the beta 1 x1, beta 2 x2, but beta k xk. Now over here, the question is, let's say this was a linear regression framework. Now this is something that you can very easily associate with the linear regression framework. The linear regression framework. Now what happens in a linear regression framework is that this y is a continuous variable. So given any values of beta and x's, some product of betas and x's, I'll end up with some values between minus infinity to the plus infinity, right? So you have y as continuous and you can easily do the models, right? You can easily understand the models. Now for a scorecard or for any risk models, the dependent variable is categorical in nature. The moment y becomes categorical in nature, so for a risk model, what happens? This y belongs to 0 and 1. So now the moment this happens, or this assumption comes in, you know that the choices of these betas and x's together, the sum product of the betas and x's, will lead you to a very specific choice of y's. Now y can be 1 under a very specific combination of betas and x's. Y can be 0 under a very specific combination of betas and x's. So it is not possible for us to develop a general algorithm right? It is not possible for us to develop any general algorithm, kind of any general algorithm to understand or to model the values of y, given that y is a categorical variable, right? So from here, the next question begins. That how, so if we need to develop the model, or if we need to develop a scorecard, if we need to model this y equals to 1 and 0, we need to have a continuous kind of a variable. So what was the next most easiest transformation, the next most intuitive transformation that we can think of? So the next most easiest transformation that we can think of is probability of y equals to 1. So what I'll have is probability of y equals to 1. So now they say that what we need to do is instead of trying to identify whether y is 1 or 0 given the values of beta and x's, what we'll try to do is we'll try to identify the probability of y equals to 1. Right now, when I'm trying to identify the probability of y equals to 1, I am getting the following advantages. So what is my advantage over here? I get to see that this belongs to minus infinity to plus infinity. No, sorry. This belongs to this, I mean, this does not belong to minus infinity to plus infinity, but rather it belongs to 0 and 1. Right? So this is probability of y equals to 1, which belongs to 0, comma. Now think of the mapping. So what I'm trying to do is I'm trying to map this expression, this sum product, right? So which is, so this side belongs to, it can take any values between minus infinity to plus infinity. Now again, this mapping, this is being mapped to the dependent variable probability y equals to 1. Now to a fractional set. So again, I need to choose the betas and the x's such that it ends up in a fractional set. So again, this cannot be done without, I mean, this cannot be done using any general algorithm. So I have to put in stringent assumptions to ensure that, okay, this thing actually happens, right? So this is precisely what the idea is. So now what we have over here is the probability y equals to 1, where it belongs to 0, comma 1, and it has minus infinity to plus infinity, and y equals to beta x1, x2, xk, and so on. So this is what the idea is, that even if I convert the dependent variable into a probability value, right, and try to estimate the probability y equals to 1, this is not really working out. But the question is, we do estimate the probability of y equals to 1, right, in our standardized models. So the question that comes out is, how do we do that? So over here, the next thing that we need to know is, or the next thing that we need to come out with over here is the following. Uh, okay. So the next thing that we need to come out with over here is the following, that I need to create some kind of a trick so that the dependent variable also becomes continuous in nature and my independent variable is also continuous in nature. So how do I manage that? Now to manage that, so to manage that, I mean, a very interesting trick has been done. So instead of directly trying to estimate the probability y equals to 1, people just go a roundabout way. So what they do is they first define the odds of an event. So instead of trying to estimate the probability of y equals to 1, what I do is I try to estimate the probability of, I try to estimate the odds of y equals to 1. The question that comes out over here is, so what is the odds? Or how do I define the odds? The odds are defined as the probability of y equals to 1 the probability of y equal to 0. Right? So over here, probability y equals to 1 and probability y equal to 0. Now from here, the next thing comes up. So if you have a look into this, you will see that probability of y equals to 1 belongs to 0 comma 1, right? It is a fractional value. Probability of y equal to 0 is a fractional value, and but this particular ratio that we have is a value which is greater than 1, is a value which belongs to the interval 0 to infinity. So it is always a positive value which can be greater than 1. How? Let's say probability y equals to 1 is zero point 0.7. So y equal to 1 is 0. 0.7, and probability y equal to 0 will be then how much? 0.3. So what is the odds of y equals to 1 to occur? What is the odds of y equals to 1 to occur? Y equal to 0. So it will be nothing but 0 0.7, 0 0.3. So this is nothing but 7 by 3. Right? So if I talk about it as 0 0.7 divided by 0 0.3, so it's like 7 by 3. So over here, what we need to do is you have a probability y equals to 1 and a probability y equal to 0. So this 7/3 ratio is greater than 1. So you can see that the odds are greater than, I mean, it's greater than equal to 0, but it is less than infinity. So it's a positive value, but it's flowed at 0 because it cannot exceed 0, right? So you cannot exceed 0 from here. So over here, the next question that comes out to us is the following: that the next question that comes out over here is that how do we make this into a continuous interval? Because the right hand side of the equation, which is beta 0 plus beta 1 x1, is still minus infinity to plus infinity. It can take any positive value. So even if it is positive, I may not be able to run the regression. So what I need to do is I need to convert this into a categorical value. I mean, I need to convert this into a continuous range. So what we do is we take a simple log transformation. We say that, okay, you look into the log of odds first. You look into the log of odds. So, say suppose if it is 7/3, then log of 7/3 is a positive value. On the other hand, if probability y equals to 1 was 0.3 and probability y equal to 0 was 0.7, then it would have been 3/7, which is a fractional value. Now, the log of a fractional value is a negative value. So, the log of odds varies from minus infinity to plus infinity. Varies from minus infinity to plus infinity. Now, when this particular thing happens, then you know that, okay, yes, this is where the entire challenge is. So this is where, and this is why, when we are trying to develop a logistic regression model, right, the model that we are building on over there, the dependent variable has log of odds. So basically what you have is the log of odds. So over here, what we have is the log of odds. This is equal to 0 plus beta 1 x1 beta k xk. So this is precisely what the framework is, right? So over here, when we are trying to estimate the dependent variables, this side should be the log of odds, right? That means the x1s and the x2s that we have. So if you are trying to estimate the log of odds, you have to have your x1s and x2s also in terms of the odds. So to explain log of odds, you can explain log of odds as odds, right? And that odds is nothing but your weight of evidence. So this is the reason why weight of evidence is actually used as an approach to transform the data, right? Because the dependent variable that you have on the other side, which you are trying to predict, is your log of odds, right? So is this explanation clear to us? Because from an interview perspective, guys, this is something very important. And given that you guys may plan to put things, flex your muscles up during this season of April May coming forth in 2019, these questions would be very critical because they would be trying to test your basics right at the beginning and then admit you into the domain. So this part is something which is important. So is the explanation clear to us? Okay.
Yes, ma'am.
Okay. Fine. Okay. Fine. So following this, so the question, so therefore, we need to understand that how is it that weight of evidence is being derived. So let's think about weight of evidence something like this. Let's say you have a variable x. You have a variable x. Right. Now x has three categories: 0, 1, and 2. Now the question is that how do you know? The question is how do you know that x1 will have a very good distinguishing capacity? So to do that, now what we look into is first is the percentage good. Look into the percentage good, and we look into the percentage bad. Now, if you think into about this percentage good and the percentage bad, so the percentage good is the total proportion of good borrowers, right? The percentage of good borrowers. So that means percentage good and percentage bad. Now percentage. So how do we define percentage good? So percentage good. So percentage good is the total number of goods in a category or goods in a category. So goods in a category divided by the total number of goods. Total number of goods. So what you can see is that this percentage good that I'm talking about is kind of a probability of y equals to 1. So it's an observed probability of being good based on the historical distribution, right? Let's say in the data there are 700 goods, right? So there is 700 and 300, right? So what we have over here is we have the percentage good and we have the percentage bad over here, right? So let's think about it like this. So when I say percentage good or percentage bad, so let's say that the 700 good is designed like this. So this has 230 goods that we have, right? So this has 200 and so 230 goods is this, or let's say 260 good is this. 230 good is this, 490, and this contains 210 goods. Right. So you can see that as you move across 0 to 2, your number of goods decrease. So your percentage good in this category is 260 divided by 700. Let's say out of this contains only 60 goods. This contains 120 goods. So it is 180. It's 130. It's 100 goods. 60, and this other is 140. So this is the number of bags. The percentage bad over here is 60 by 300. So what you can see is that this percentage good and this percentage bad is the probability of y equals to 1. This is the percentage y equals to 1, but this is the observed percentage of y equals to 1. Right? Because you are doing it from an observed distribution of the variable. So therefore, this percentage good is nothing but equivalent to your probability y equals to 1. Similarly, your percentage bad is your observed probability of y equal to 0. So when you do this log of percentage good by bad, by bad, log of percentage good by bad, this is your weight of evidence. Right? So is this part clear? So what we can see is when we talk about this weight of evidence, the weight of evidence is nothing but the observed log of odds, right? And you are using this observed log of odds to predict a log of odds for the dependent variable. And this is how this transformation, this is why this transformation is used. Sorry, Piyush. Yeah. So this was a small mistake. I jumbled up the y equal to 1 and 0 over here. It should have been the other way around. Sorry, it would have been percentage bad by percentage good. I'm extremely sorry for that. So y equals to 1 is, if y equal to 1 is your defaulter, then it's the percentage of bad. If your y equal to 1 is your good definition or your borrower is good, then that becomes your y equals to 1. So that part of your y equals to 1 is your uh, so basically it's event by non-event. So I just jumbled that up over here. Thanks for pointing that out, Piyush. Yeah. So log of odds, no, that's not odds ratio. It's log odds. Odds ratio is something separate. This is simple log of odds. Huh. Log of odds is always event by non-event. Sorry. Yeah. So is this idea clear now? Okay. So Umang has a question over here. So this is the values of each risk. Okay. So the question that comes, so the Umang has is that also the values of each risk category is percentage good. What does it signify? Okay, so percentage good is, so how do I define percentage good? Number of goods in a category divided by the total number of goods. So this is in percentage good. 260 is the number of goods in this category divided by 700, which is the percentage good. Clear? Umang? So over here I've computed the percentage good using this formula. This is the formula for percentage good. The number of goods in a given category divided by the total number of goods is your percentage good. Right? Yes, and this is computed for each risk category because the next stage is to compute your information value. Yes, so this is done for each risk category. Now, so weight of evidence transformation helps you convert the entire data into a log of odds kind of a framework because your dependent variable is log of odds. So using the observed log of odds, what you're trying to do is you're trying to predict the log of odds, the dependent variable. So that's the framework, right? Now comes the next part. Okay. So now from the weight of evidence, we move into the metric of metric which helps us discriminate between the good and the bad categories. So what is that? So that measure is your information value. Okay. So the next part is information value. So how do you compute information value? Now, information value should give you the distinguishing capability of a variable, right? So over here, what we'll write is your information value, right? Fine. So information value, the first thing that information value does is the percentage good Hey, hi guys. Am I audible? Sorry, I had to go on mute. Okay, perfect. So over here, what we have is the information value is percentage good minus percentage bad. So the greater the difference between the distribution of the good and the bad is, it means the category has the greater distinction capacity of between good and bad, right? So the more number of goods, so the more different the number of goods and bads are, the better is the distinction capacity of the variable, and hence percentage good minus percentage bad into the log of percentage good by bad. So this will be your percentage event minus percentage non-event, right? So I'm just writing good bad because in line with the weight of evidence definition that I had written. So as per my as per the dependent variable, it should be percentage bad by percentage good. So it's always event by non-event. Percentage good by bad, right? So this is the information value, and the information value does not occur at a category level. It happens at a variable level. So across all categories, you compute the difference, right? And then you add it up across all your categories. So that means the information value for this will be this difference, this minus this, into the weight of evidence. So for each category, the information value would be computed and it would be summed up to reach at the information value. So information weight of evidence is reported at a category level for a variable, and information value is reported at a variable level. So you add them up, all you find them out and compute the information value. So that is what your information value is. Right? So is this concept of information value clear to us? Great, great. Okay, fine. So the information value, or IV as we call it, has certain cutoffs. Or so these are not any test, any statistical cutoffs, but these are industry standard cutoffs. So if your information value is less than 0.01, this variable, or the variable that you are using, is an unpredictive variable. Is an unpredictive variable, and these variables are generally dropped, right? So is greater than equal to 0.01, less than 0.03 is predictive. Predictive. And information value greater than equal to 0.03 is highly predictive. Is highly predictive. So these are the three. So these are three more standard bands. Now some organizations also do more granular rating, and you have more bands of high prediction, low prediction, etc. So this is precisely how your information value structure looks like. Clear? Now, if unpredicted variables are removed from the data, predictive and highly predictive variables are retained. So this is precisely how your information value framework, how your variable selection framework works. Right? So any queries up to this point? Just go through this analysis. Right? Just go through this analysis. I'll just take a break for 5 minutes, right? 5, 6 minutes, and I'll be back. And then we'll get started with the model development frameworks. So after you have selected the variables and variable selection is completed, now you have all those variables which are structurally proper. I mean, which not having structural issues, as well as they have these variables are highly predictive. So you have filtered out the predictive and highly predictive variables from the model, and now next part is you want to develop your model, right? So where we'll talk about the logistic regression models, right? So what are the core components of these models and how to validate these models and so on, right? So once we complete this entire framework, then we'll start working with the data hands-on, right? So we'll start with the model development exercise following this, right? So just have a look into this, and I'll just be back in the next 5 minutes. Thank you.
This conference will now be recorded.
Hey, hi guys. Sorry, I was a bit late. Okay, so any questions up to this point? Hello. Yeah. So all of us are here. Anshul, Harish, Minmoy, Piyush, Umang. Yeah. Great. Fine. So any questions up to this point? Anything that you may not have understood? Okay. Fine. So out of the discussion that we've been having, right? So we are talking about this framework of the scorecard and its development. So we have talked about the scope and the gap analysis. We have talked about the identification dependent and the clean dependent variables. We have talked about data extraction. We have talked about data quality check. And now we have discussed about the variable selection exercise, right? So the next stage of this analysis is the model development. So before I go on, right, before I move on to model development, let's say you appear for an interview and someone asks you, what do you think is a model? What do you think is a credit risk model? How would you be defining it? Yeah.
um, Tanmay, something that you mimic a system through data, that you can call it as a model.
Okay. So what do you mimic in the system?
With the help of
What?
data.
Yeah. So what are you trying to mimic? Not. Let's not use the term mimic. Mimic is a very negative word. So let's use the word replicate, right? So what is it that are we trying to replicate?
We're trying to replicate a system.
Okay. So what system? What type of a system is it?
For
How do you
example,
define that
acquisition.
system? No, no. How do you define that system? What are the core components of that system?
With a mathematical equation with some which follows some
Okay.
distribution.
Okay, fine. Mathematical equation. What type of an equation? What are the core components of that equation?
I mean, it has an
So,
intercept.
no. So basically, what you are trying to do is you are trying to replicate the factors or the key risk drivers that impact a dependent variable, right? So your dependent variable is a replication of your true business problem, and your independent variables are your key risk drivers. Now what you are trying to find out is that how can you replicate the causality between your dependent variable and your independent variable. So what are the key risk variables in your portfolio which on average drives the dependent variable? So that is what you are trying to identify using this particular model. So when you talk about models, be it credit risk models, acquisition models, behavior models, Basel models, whatever it is, you are trying to assess, or you're trying to understand the average with the factors, the key factors which on average impact your dependent variable, right?
Yes.
So that is the core part of models, right? So this is a very trick question, when people ask. Now, it's a very common trend in credit risk interviews to ask you, okay, what are the models? What are the models that you have developed? Right now, in the one of the most recent interviews that I had given, like when I was moving from planning a switch from UI to back to the captive banking sector. So one of the interviewers asked me, so he was based out of UK. So he said that, yeah, we all talk about models, but what are models? Why are we building models? Right? What do you think should be the average longevity of a model? So, so that's the part. So, when you are trying to, when we talk about these models, we often do not very consciously look into to understand that what exactly that we are trying to do, right? And interviewers often try to look that deep, that the basic, into understanding that do you realize what you are actually doing? Because what we generally do is we do it as a part of a process, right? As a part of our deadlines, as a part of our projects, but we don't realize the crux of the thing that we are doing, and that's where I guess this question comes from. So basically, whenever I'm talking about model development, so I'm talking about assessing. So I have a portfolio with me, and this portfolio represents or reflects a overall or an average behavior. And when this average behavior over a period of time is done, right? So when we look into this behavior of the portfolio over a period of time, what we do is we try to assess that, okay, this is what the business problem is, and these are the factors which explain the business problem for me. So what are the factors which on average explains the business problem? So this is where the question, or this is where the part of model comes out. Model helps us in looking into that, into the underlying causality pattern across the variables, right? So now because we want to understand that how does variable x1 impact y, x2 impact y, x3 impact y, right? So you would see that that is to ensure that we can actually capture the independent impacts of x1 and x2 and x3 on y. We do all these data quality checks, we remove all missing values, and we are trying to get into a platform where we are able to capture the relationship between the dependent variable and the single independent variable, and we can independently capture those picture, right? So that I know that, okay, if I move this driver up, how does that impact my dependent variable? So if I move x2 down, everything else remaining unchanged, how does that impact my dependent variable? So that is what we are trying to essentially understand, right? Right. So this is what. So this is the basic idea of your models. Now, in credit risk models, be it your acquisition models, behavior models, we have a dependent variable which we have discussed there, and we try to identify the key risk drivers, x1, x2, x3. So some part of it we have already discussed over here, right? So the basic exercise that we see is we we have the log of odds as the dependent variable of the regression, and we have certain algorithms which we use to estimate the beta ones, beta twos, like these. And what we tried, and beta 1, beta 2 over here, so these are the the causality coefficients. This shows the extent of x1, that if x1 was to be increased, everything else remaining unchanged, what, by how much would the log of odds change. So this is what your models are. Now when we talk about models, we'll generally talk about two broad kind of models. So So one of the models that mostly when we work in our credit risk modeling module, we'll talk about the following three models broadly. So over and again, you will see these models coming up. One of the models is your decision tree algorithms. Decision tree as the classification algorithm. Now, decision tree algorithm is one of the most fundamental classification algorithms which we have been using, and whose advanced versions are like random forests, and you have your GB boosting, XGB boosting, and whatever it is. So you have all these kind of things, right? So over here, what we have is the decision tree. So decision tree is one of the most fundamental algorithms of machine learning, right? So whenever you start off with machine learning and all these advanced algorithms, decision tree is one of the most fundamental algorithms, right? So after having talked about decision tree, the next set of algorithms that we have is the linear regression. A linear regression is another very interesting uh, algorithm which talks about how the dependent and the independent variables are related to each other, and how is it that they can be used to estimate the causality. So linear regression is a regression methodology which is used to kind of uh, understand the causality between x and y, where y is a continuous variable. So we'll talk about these regression methodologies. So when we talk about predictive modeling or scorecard or model development, these regression methodologies will be coming in again and again. And these are the three broad modeling methods which you need to be very sanguine of if you are developing these credit risk models, right? So these three are also these three form, you know, the very base of your data science fundamentals and everything. So these are parts that you need to be very clear about,
करो मुझसे नहीं याद है
right? So the next part is the logistic regression. So these are the three broad modeling methodologies whose framework we will be discussing. Now, before we discuss these three modeling frameworks, right, we also need to talk about something about the statistical prerequisites about these modeling frameworks, right? So we need to talk about the sampling methodologies. We need to talk about the theory of estimation. We need to talk about variable reduction algorithms like PCA, clustering, etc. So clustering PCA will not be discussed over here very exhaustively, because I'll be talking about mostly about decision tree linear logistic. And another algorithm which will be very critically discussed, that needs to be discussed, is the survival analysis. So these are the four broad statistical modeling methods that we need to discuss while we talk about model development. Even though they would be used for different purposes, like logistic regression will be used for behavior application scorecard as well as a PD model. For doing the LGD models, we talk for doing LGD models. We need to talk about linear regression. We need to talk about nonlinear regression models like gamma regression, beta regression, and so on. We need to talk about logistic a little bit again. For EAD models, we need to talk about linear regression decision tree models. And for while we talk about IFRS 9, we need to also talk about the survival analysis models, right? So these are, so as we go ahead, as we progress, these methods will be coming in again and again. So after we have finished talking about the scorecard development framework, right? So after that, we'll start talking about the statistical models to some extent. Or what we'll do is we'll go through the data preparation exercises for the respective models first, and then we'll start our discussions on the statistical sides. And then we'll pull in the modeling exercises and we'll develop models and we'll do it that way, right? So that's going to be more or less, so we'll be working around that part as we go ahead. So these are some of the important exercises, statistical modeling exercises that we need to work around as we progress. Right? So survival analysis is one. Also, beta and gamma regression will be one while we talk about LGD and especially about LGD, because LGD regression distributions are kind of skewed distributions, so they can easily approximate using beta and gamma regressions. But before that, we need to talk about what beta and gamma regressions are, right? There'll be a lot of quantitative discussions coming up as well, right, on the modeling side of things. But for the time being, we'll just restrict ourselves to understanding what a model is. Right? So basically, a model. So when I talk about any statistical models, it is a model is nothing but a model is an element, or it has a kind of element of causality. So a model explains causality. But the question that comes out is that, okay, I do understand that your model explains causality, but you use your historical data to to predict your future. The question again that comes out is that how do you think, so how do you think, or how can you assure that this behavior of your dependent variable will follow up on your, I mean, the historical behavior would follow up in the future as well. So how do you know that your prediction is reliable? So what the modeler says is that when I do this prediction, I work on a very specific assumption that the future or the past explains the future. Explains the future. The past explains the future. Right? So when I talk about the past explains the future, so the assumption again behind the statement is that the average behavior of the past continues into the future. So when we are developing models, we are developing, or we are trying to predict the average behavior. We are trying to predict the expected behavior, right? So the average behavior of the past continues into the future. So what we are trying to, in while developing models, I repeat, we are trying to predict the average behavior that is possible to occur in the future, given that a particular average behavior prevails in the past. So this is precisely what we generally do, right? Now, any kind of diversion or any kind of diversion from the average behavior cannot be explained, and that is treated as the occurrence of a of occurrence of an error term or a random term and so on. So what we need to do is we need to know, so in models we need to uh, form an average idea about the future given the average behavior in the past, right? So in models, how is it developed? What are the algorithms? What are the basic algorithms? So these are something that we'll discuss in the next class. That is in tomorrow's discussion, right? And after that, what we'll again do is we'll talk about how the model can be validated and so on. Clear? Great. So thank you guys. Thank you for your time. We'll catch up tomorrow, right? And as we move on, we will be talking about these. So once we finish the framework, right? So as we go ahead and start talking about the statistical models as well. So once we finish this development framework, the validation framework, then we'll start working with the data. So I think we have still 1 week to go before we finish discussing the framework and we start working with the data, right? So I believe next week onwards or next to next week onwards, we'll start with the data. So thank you guys. Thanks a lot. So tomorrow we have both the CRM as well as the IFRS and workshop. So let's meet for the same. Bye bye.